we need to be able to quantify how much solute is put into a given amount of solution. And so we have a formula. I don't really like to use it as a formula. I like to understand it as an idea and then to be able to use unit cancellation to be able to determine what we need. You'll see as we do calculations. So, concentration of a solution is equal to the moles of the solute that you have, so you have to turn a mass of that solute into moles, divided by the liters of solution, not solvent, solution. Because, you know, if you have 100 milliliters exactly of a solvent, you put the crystals in, the solution level goes up, and now you have a certain amount of moles of chemical in a volume of, not solvent, but of solution now, because the particles that you just put in take up some room and increases that level of solution as opposed to what the solvent was originally. So, moles of solute divided by liters of solution. And how do we abbreviate that? How do we recognize that with a number in front? We use moles per liter, moles over liters. How many moles do we have over 1 liter of that solution? You're also going to see moles per liter written as big M, because big M is molarity, and molarity means concentration. So this is, concentration is moles per liter, so it's molarity. Okay. Now, another way, of course, of writing per something is to put that thing that's in the denominator back into the numerator, but putting it to a negative exponent, right? -1 exponent. So moles times liters to the -1 is a way that some people write that. You know, if you're writing a textbook sort of thing and you don't want to go moles over liters and occupy an extra line of space or something like that, you actually write it all on one line and put the liters to the -1. And then when you're taking IB chemistry, moles per decimeter to the -3, because a cubic decimeter is actually a liter. You're going to have to tell me if you use that unit, because I don't know who uses that unit except for the IB exam. So once a year you have to write and understand moles per cubic decimeter is actually a liter. I don't use that. I use moles per liter and big M because it's easy. Let's do some calculations. Alright, now let's do some questions where our understanding of concentration, being moles of solute divided by liters of solution, comes into play. You got 10.0 grams of sodium hydroxide in a 200 milliliter solution. What's the concentration? What I like to do is I like to start with that mass and then work my way through in a unit cancellation method to be able to determine the answer. And you should too. So here's how it goes. You got 10.0 grams of NaOH. Look at that. I like to put that chemical name next to that mass that I've got there and then say to myself, I don't want grams of NaOH, I want moles. And I know that the molar mass is a ratio of grams to moles. So, because my periodic table has always 2 numbers after the decimal for a molar mass, when I add all of those up, even in a calculator, I don't use the number 40, 40.00, because I want to keep 4 significant digits, 2 numbers after the decimal, and all those molar masses. And I go 40.00 grams of NaOH, and that put that mass in the bottom and the moles on top. That's the grams per mole. But I've inverted the molar mass unit, grams per mole, as moles over grams to be able to cancel out the grams. Now what do I got? Moles of NaOH. Well, I'm almost home because you know that concentration is moles per liter. So now, take that mass, that number of moles that you've got there, and you're going to divide by the volume. Now look, you're going to say, Chem guy, I see it right now, man. Why don't you just put 0.2 liters here? And I can. No, that's fine. Actually, I wouldn't write it like that, would I? Because if I give, and you get, 200 milliliters of solution, we're calling that 3 significant digits. That's what we do where I live anyway. We call that 3 significant digits. Some would just call it 1. Let's just say 3 for now. So you got 3 significant digits there. Okay, well then you better keep, if you're going to put liters here right away, you go 0.200 liters, right? Don't drop digits. Bad form. So now, what you want to do, if you're doing it this way, is just say, well, okay, I've got the moles and I'm dividing by the volume, and it's in milliliters, but I don't want milliliters, so I want liters in the bottom, and there's 1,000 milliliters in 1 liter. Beautiful, isn't it? Now, when you do that math right there, multiply all the numerators and then divide by all the denominators, you're going to get, in this case, 1.25 on your calculator. By the way, 3 sig digs 4, infinite 3, infinite, and infinite in this ratio here, because there's exactly 1,000 mils and exactly 1 liter. And you get 1.25, and you can write it like this. Big M, moles per liter, just go moles over liters, moles per liter of NaOH. That's beautiful. That's beautiful, that question, wasn't it? Now, How about the next one here? A little bit different. So you calculate the volume of a 0.20 mole per liter solution, and then I give you the mass that it was formed from, 12.3 grams, and the chemical is lithium sulfate. Okay, so how do you do that? Well, I'm starting with the mass again here, and I'm going to take that 12.3 grams of lithium sulfate, going to find that molar mass of lithium sulfate, which is 109.95 grams of lithium sulfate per mole. Now, where do I go from here? Well, what do I want? I want volume. So in the end, I want the volume, but I don't want moles. That means that I've got to have something that cancels out the moles of the Li2SO4. And what is that? Well, we've got a concentration here. Remember that big M stands for moles per liter. So that's how many moles of lithium sulfate you have per 1 liter. Oh, well, okay. So 0.20 moles per 1 liter of the lithium sulfate. By the way, notice that I always put the chemical that's being described in terms of moles and grams next to those units. But next to liters, you don't ever put down the chemical name unless it's a gas, and we talk about that later. And that's just because of the fact that you don't really have liters of lithium sulfate. You have liters of a solution that is mostly water and a little bit of lithium sulfate, okay? So don't put that chemical name there next to liters when we're talking about solutions. Hey, all right, look what we've got here. We've got grams canceling, moles canceling, we've got liters left over. That's what we want, the volume in liters. Okay, so now, when you do the math here, you're going to get 0.559 liters, but look, 3 siggy diggy, 1, infinite siggy digs, you got 5 there, you got 2, you only got 2 there, so you got to keep 2 significant digits, and so that's going to be, right, 0.56 liters, and that's all you have to write there, of solution. So that's how you do questions when you've got masses involved, but you're calculating concentrations, and here you're calculating volume.